All right, so last time we were introducing the idea of JavaFX and how the library is set up. We went over the actual setup of the IDE. I showed you guys a way that I could do that in IntelliJ. As I mentioned, that's not the only way, but that's definitely one good way that you can use. You can also invoke JavaFX from the command line, but as far as you are able to somehow invoke that, have it running, I'm good with that. And obviously, you are able to do your test and have test the code that we provide, and also work on the homework that you are expected to produce a class that implements a GUI, right, a graphical user interface. So we show this hierarchy of classes and interfaces that we have. So as you see, the parent-most class that we have is node. So for instance, if you would have the need to create a button is a subclass of control, which is a subclass of region, which is a subclass of parent, and parent is a subclass of node. So this hierarchy, these diagram here, I think it really helps you understand overall the idea of what you can do in terms of setting up your graphical user interface. And that boils down essentially to just picking the right classes to have the elements constructed on your window. So for instance, if you would want to add labels in your windows, you would be using the associated class. So you just instantiate an object of that specific class. If you want to add a button, same idea. There's also some classes that are related to the layout of what's going to be on your window. So that's a way for us to organize how things would be distributed. And I believe I have shown already last time some examples of that, but if not, I will do that one more time. We have these three main classes that are related to the kinds of panes that can be created: the grid pane, the flow pane, and the border pane. And that essentially just allows us to distribute the objects in different ways, right? So the grid panel, as the name implies, you essentially have a grid where you would be putting the elements in each element of that grid. So you can think of it as a matrix or a table that has a very fixed layout. I also mentioned that these would most likely be one of the layouts that you could use on your solution, because in the homework we have a game where you would be putting the balls on the idea of these columns, right? So you could easily represent those columns, those pipes, those however you want to call it, that would be housing the balls as columns in a grid. You also have the flow pane, which is just a more fluid layout where the elements would be distributed along the available space that you have. So I even use the example of web development, where it's quite typical for you to have the elements responding to the shape. So as you resize a given windows, so for instance, if you are in the phone is one thing because you have a given shape and a given resolution. If you move to a computer, you have more space, so it's a different setting. Usually you have more resolution and or at least more space. So you can play with that to essentially have your elements distributed in the available space that you have. So that's the idea of this fluid layout that we have in the flow pane. And finally, we have the border pane. So the border pane is another very structured kind of layout where you would have regions. The regions that we would have would be the top, the bottom, left, right, and center. So depending on the region that you choose, your element would be in one of those spaces there. We can go ahead and check out some examples that we have. So let's go first with the border pane. Let me run the program, and then I think it's easier if you first visualize the result and then we go over the code. So if you check here, this window that I have these different regions, these different places, right? So we don't have any line to separate, but this essentially gives you the idea of the regions that we have. Well, let's take a look at this code. That's also a way to review one more time how to create an application that uses JavaFX. So you need to extend from application that is part of JavaFX. Should be in your imports. Okay. Then I am just setting these values here, the width and the height that I want. I would pass that to my stage later on. So as I have mentioned last time as well, you need to have a sense of the workflow or the sequence of methods that are invoked by the application. So at the beginning, what you would see is the constructor of the instance itself being invoked. So that's just the regular constructor that we are used to. Then you would see the init method being called. Let me actually show you the example where we did that. So if you see here, you have the init method, and then you have the constructor that I mentioned. You have the start method that goes, as the name implies, when you start the interface. That's usually when you would call the show method to have the elements being presented in the window. And then finally, when you shut the window, when you close the window, you can have a method that would execute some sort of command, some cleaning up that you need to do, or just really some message that needs to be printed. And then you have the main method that in this case, I am explicitly calling the launch method on that application. We also mentioned that this is actually optional on a JavaFX program. So contrary to most examples that we would see on Java classes, JavaFX would actually perform these launching for us implicitly, even if we don't specify. So this is essentially just to show the sequence, right, of things that would happen along the way of my execution of my JavaFX program. So the main function is being executed, the object is being constructed, the init method is being called, the start method is being called, and then finally, when I close the window, that's when the stop method would be executed. Okay, that gives the essence here is just to go over the sequence of things that are happening over the life cycle of my JavaFX program. So let us go back to our border panel demo here. So we have the start method here implemented. So the first thing that I'm creating is an object of type border pane. If you are not sure which elements you should choose, again, a very easy material that you can use is this diagram here that I made available to you. Another good resource, obviously, is the documentation. So if you go to the node that I should have here, you would see all the possible subclasses, so you can navigate as well and explore everything that you can use. So for instance, let's say if you want to see where the button would be, so you would need to traverse the hierarchy until you reach the button, right? And the button was the example that I used because it has a lot of parent classes, super classes. So you would need to go from node to parent, region to control to finally arrive at button. And you can see that if you navigate the documentation, right? So parent, region, right? Control, and all these obviously you might get to know a little bit more about those, because there's some common methods, some common properties that are shared among these elements. So have should have button here. So for some reason I don't. But as you can see, oh, that's because it's a child of labeled. So labeled, then button based, and finally button. So it's a little bit more involved than what is being shown in the diagram. Okay, so that helps essentially for you to get to know a little bit more about the classes that you would be using. Back to the code. So here I am just instantiating a border pane. So a border pane would be essentially a sort of a component that would establish this layout as that idea that we have presented. I am creating next a label instance to obviously store a label. I'm initializing with the content of that label. This is just a regular constructor call on the object, right? Then I am calling setup, which is a specific method that will be available on border panes to set that instance as the element that would be on the top. That's how I am linking those things, right? Then I am setting the alignment that I want to see in that specific region as centered. Next, I am moving to the bottom. So I just did this part here, right? Now I'm moving to the bottom. So for the bottom, I'm going to do something similar. So just creating again a label that I'm calling bottom, calling the constructor, passing the message that I want to see in that label. Again, I'm calling a method that is specific to the border pane. So then these will be setting that element that we have, that instance that we have just created for that label as the element that would be present in that region. I follow the same idea here for the left part. So again, I am creating a label. I am registering that label as part of the left region of my border pane. And I am setting the alignment. I do the same thing for the right-hand side part, nothing different, and the same thing for the center. Then finally, I do the initial setup, which is, as we saw before as well, to first create a scene. And then I'm going to add my border pane to that scene. So that's how I'm initializing the scene. And then finally, I am initializing the stage by passing that scene. So remember that the stage is the idea of the overall windows that I have, and each scene would be one possible layer that I could have. So I could have possibly multiple scenes being used on the same stage, right? So the stage is just that idea of the windows. I'm setting the title to something here, and I'm setting the size, the width and the height. And then finally, I'm calling show. That is going to be the one method that would pop up the window for you after you have all that set up. Usually you do all the setup and then you call show, right? So that's how we usually go about that. So that's a fairly simple example, right? But actually quite a number of lines that we have here, but nothing very complicated. The thing that you need to be aware of is really understand the right methods that needs to be called, how you want to set up. So it helps if you beforehand have like a drawing or even a visual understanding of where the things should go. So then you are able to set up these environments as needed, right? Because we are doing that programmatically, right?
The show is for the pop-up or showing everything on the window?
Show would pop up the window when this show method. That's what you mean, right? Yeah, that would pop up the window. let's move on to any question on this one. So let's move on to the next example that we have on the layout. So I have now the use of a flow panel object. So my flow panel, similar to what I had before, I would just initializing by instantiating the flow pane class. Then here, I am going to create all these checkboxes. So I'm iterating over a number of checkboxes. I am creating one checkbox instance for each of those checkboxes that I'm creating. So I am getting the flow pane. I'm calling get children, and then get children would allow me essentially to use this method add. So that would essentially be adding one checkbox at a time to that flow pane.
What is the get children exactly doing?
So I need to call add children because the add will be available as the return type that I would get here. So if you show here. Scene layout pane. So this would return a list of observable objects of type node. I use that to call the add. So after I do that, I just set the gap, the vertical and the horizontal gaps, and then I am finally initializing similar to what I had before. So I create a scene object. I pass that flow pane to be the element that's seen, and then I initialize the stage by passing that scene. And finally, I call the show. So then you would see, we expect to see now a fluid window with all those checkboxes present, right? Let's run that to take a look at what happens. So you see all the checkboxes that have been created. And you can see that if you resize your window, the layout is going to be morphing or adapting to whatever space you have, right? That's a common characteristic that you have in that flow pane.
When you're like resizing the window, is that update method being called?
No. So the update is part of the observable and observer interface. So that's intended to create the communication between the model and the view. So that's the kind of updates that would be happening. As a result of that, you will most likely update the graphical user interface as well. But that's a different kind of update that we are observing. Okay, I will go over these two interfaces in a little bit more detail in a few examples today as well. Any questions? All right, let's see our third example of layout. Oops. The grid pane. So the grid pane now, I am defining the number of columns and rows that I want as these static fields. So here I am separating the code in a different method for convenience, right? So I am creating a grid pane instance, and then I am calling, I am creating buttons. So essentially I would have a button for each row and column that I would go over. So I'm iterating over the rows and the columns, and I am adding the specific button that I'm creating at each iteration to that column and the row that we are going over. So you are going over rows and columns, and every time that you change to a different row or column, you create a button, and then you associate that button with that specific position in your grid pane. Right. So the grid pane is the more structured kind of layout that we have, and as we said, you just expect to see a sort of a matrix or a table where the element would be sitting on one specific location. The start method is just calling that method that we saw, make grid panel, that would result in the creation of that grid panel, right? So I am receiving that and storing that variable. And then one more time, I'm just doing precisely the same thing. I create a scene, as I associate the scene with my stage, and then I invoke show to present my window. Questions? All right, so these are the three more common ways in which you would be setting up your layout. You can also compose layouts. So you can have, for instance, as one of the regions in a border pane, you can use a flow pane. So it's possible to combine those different layouts as well, right? So you don't have to stick to a single one. Now let's move on to close this. Let's move on to an example. Actually, let me first go over. No, but then this was. Let's go over this one. So here, I want to show the use of events being used associated with some graphical components. So the way that we would be registering those events is by passing an implementation of an interface that we usually refer to as a functional interface. So the function interface is the main element that you would see in a lambda expression. That's an example of that. So this is a syntax that is going to be new compared to what we see before in the course. What's happening here first is this is just a regular call on a method that is available on my first button. So my first button is that button that I have created here. So we saw that kind of object being created before, right? Nothing super new about that. What is new here is that I am receiving as an argument of that method call, this kind of expression here, right? So when you see this kind of expression, this is an example of the use of a functional interface. So a functional interface is essentially what Java decided to use to implement lambda expressions. And the idea here is that in terms of syntax, you would see the inputs that are being used in your implementation as the first element. You would see an arrow symbol here, the hyphen and the greater than, right? So we call that an arrow. And then you'll see the implementation that would be the actual implementation of that lambda expression. So essentially, there's this idea of input and output. So the input would be the parameters that I specify here, the variables that I specify here, and I can use those variables to calculate some results or not even use them. Like in this example, I don't actually use events anywhere here, right? That's also perfectly fine. And I can also have multiple, I can have that as a block, as you see here, defined by these curly braces, but I can even remove those things, and that would even still be valid if I have one single command. So if my implementation is one single command, that would still be able to be simplified just by removing those curly braces, right? So essentially what I'm doing here, my intention with that method call is to register a handler
for an event that would happen. So the event would be any change that would occur with, in this case, with that button, because this is a button, right? So when I, for instance, click the button, that's one event that would be happening. And that's when I want that event to be handled. How it's going to be handled, that's being determined by this lambda expression here. Essentially, every time that this happens, this piece of code would be running.
For event-based actions.
No. I use, so the other way is more, still is not a universal rule, but the way that you would see event-based programming in Java most likely would be either with lambdas or anonymous classes. These are the more typical ways in which you would see implementations of event-based programming.
Basically like a temporary function, right? Where like it just like takes the event value and like apps on it.
So the way that I like to think about what happens in Java is that you have an instance, so an implementation of a method that belongs to some class, right? Because a method needs to belong to some class in Java. That class follows a specific interface, right? And the reason why we call that interface a functional interface is just because I have one single method. And the reason why I have one single method, the reason why I need to have one single method is because I am nowhere actually here saying anything about that method, right? You don't see any mention here to the name of the method that is being invoked. You don't see anything. Maybe the only thing that you see is actually the inputs, the parameters that the method will be receiving. That's it, right? So you don't really see a lot about what really is going on behind the scenes. But in order for that to work, because I'm not specifying which method I'm talking about, I do need to have an interface with one single method because there will be no ambiguity. Okay, does that make sense? I know I'm kind of trying to present something fairly complex in a kind of short amount of time, but try to think about this, not so much in terms of everything that is happening, but more in terms of the syntax, right? So if you just follow this syntax, you should be able to do pretty much anything that you want with respect to that JavaFX component.
So like set on action when we do on like force the button, like that like just takes a event quote unquote parameter and like we can act on that event parameter like
right.
Set the lambda.
Yes.
If I followed it properly, like lambda expressions, this is one place that we have used.
This is the first time that I am showing you guys a lambda expression. Yes. Right? So we did not see that syntax before.
Yeah, so the question was related to, are we going to get more into lambda expressions or?
We will. So, but I am anticipating because this is the typical way in which I would register an event handler, right? So I don't want to.
So my only intent was, do I need to learn more about lambda expressions now, or I just follow the?
No, you find I can even make the material available to you, but I would actually recommend you not spending so much time on that. Focus on the JavaFX piece of it, right? And if you follow the syntax, even without fully understanding everything that is happening here, you should be able to actually register every comment that you need to be performed when some action happens on that button.
Yeah, so the syntax is quite intuitive. I just want to know more about how things are happening.
Yeah, that's kind of personal, but I would probably suggest you postpone that a little bit. Yeah. Okay. I can show you the set on action method to give you a sense of the kind of object that we would be passing on. So this is the event handler interface. So if I show I think I have it open here already. If I show you, the event handler interface, you would even see on functional interfaces that there's always this message present in Java doc. So this is a function interface and can be used as the target of a Lambda because you only have one method, right? So that's essentially the requirements for you to have a functional interface. Okay. The name of the method you didn't even know before I showed you here, right? So this method is the method that actually you are implementing by that Lambda expression that you are providing. Okay. That makes sense? Yeah, if you never worked with Lambda expressions before, it takes a little bit of getting used to. We actually have a topic just on that, especially to introduce you to the idea of functional programming in Java. This was something that was introduced in Java fairly recently. So I believe Java 11 was the first one that has. I'm not sure. I can check. This was not one of the first versions of Java that have that been implemented. So it's something fairly recent in terms of the functionality that you would see in Java. Okay, any questions? All right, let's move back to our code here. So yeah, again, just don't worry too much about understanding everything that is happening here. Try to abstract a little bit what's going on here. You're really just registering this kind of implementation of the event handler that would just have those commands, in this case, a single command that would be executed every time that that event happens. Okay, that's one example of the registration of an event, and more generally the event-based programming that you would see a lot in JavaFX.
In that block, I can have any sort of code inside that.
Yes, you can do pretty much anything, right? So the same thing I'm doing here for a second time on a different button. In this case, I have created a horizontal box. I did not mention these HBox before, but that's also a kind of layout that you can have. So it's just a box that is arranged horizontally. I have created the first and the second as buttons, instances of button class, and just setting the labels that would be in those buttons. Then I am adding these two buttons to my HBox, so similar to what I did before, setting the alignment, and then finally setting up a border pane and putting the HBox at the center of my border pane. Right, so this is already one example that I have mentioned before, where you can compose layouts by combining those different panes and components and visual components that actually house other components, right? The last piece here is the same as what I had before, so nothing new. Right, so let's just see the result of my implementation here. I would expect to see now my buttons reacting to the click, right? So if you come here and you click, you would see that this label has been updated. Second has precisely the same implementation. So this is a simple example of events being registered using Lambda expressions and performing actions as part of my Lambda expression. Okay. Any questions? Nope. All right. Yeah. No, that's fine.
Is there any function over here to like check the number of times that it gets pressed, like double clicks if I want to add it?
If we implement that, there's no built-in counter, but it's just something that you can implement, right?
I thought
just create some counter field or even local variable, depending on where that's being executed. Probably more like a field, and then you accumulate that.
I just thought that, is there any automatic thing?
No, no built-in functionality of this type. Okay, so that's the first example. This is a little bit more involved example. Here I am using a number of image objects. So we introduce a new type of component here. And if you check out here, I am initializing my images by passing an IO stream that is constructed from that file name, right? So this is also something that I did not show any example to you before, but this is also very common actually to see on implementations. You just call get resource as a stream. You pass that as a you pass the file name as an argument, and then you would receive as a result an input stream instance. That would be the kind of result, and you do need to have obviously an input stream as the parameter for my constructor of image. Right, so if you check image, you would see, do I have that here? I don't.
It's only from the local resource.
Yeah, so you would typically just be looking at the current directory for that image or for whatever kind of file that you would want to access, right? So that's the constructor that we would be using.
Okay, I can start the URL.
Yeah. Okay.
URL one isn't the IO stream way, right? I think so.
URL is a string. Yeah. Okay. All right, so I'm creating those image objects, right? So I'm also creating a background object. So similarly, you would just check out the constructor. This constructor will take this background fill kind of parameter. So then you would be specifying the color, the corner ready, and the insets. I don't even know what that means, but you can just check the documentation for that. I am creating a label. I'm creating. I'm setting the some constant here, and then I'm following the same idea as I did before in the grid pane example. I have a method that would construct the grid panel for me. I instantiate my grid panel. Here I am creating an array with my Pokemons. Then I am going over the rows and the columns, and every time that I go over one of those, I create a button. Pokemon button is a class that we have here. I'll show that in a bit. So I am instantiating that and calling the constructor, passing that specific Pokemon value. After I construct that button, that is, as we will see, just a subclass of button, I go ahead and I register an event. So same idea as what I did before. I pass a lambda. In this example here, you see that you don't have the curly braces, right? So that's as long as you have one single command, that's perfectly fine. You also can remove the parentheses here if you want. These are more simplified syntax. And here I'm just changing the text of the label, right, with the value associated with that specific button. And then finally, I'm adding each button to a specific location in my grid, in my matrix of elements. So let's take any questions on that method here. So let's take a look at the button implementation. So here I am creating a subclass of button that I'll be using. As you can tell, this is somehow related to Pokemon, right? So I have a Pokemon field here. In Pokemon, we have also create an enum. Yeah, we have this enum for the Pokemons, right? So here I have the constructor of my Pokemon button class. I am receiving a reference to a Pokemon. So then I am setting my field to that value that has been received. I am creating an image, and then based on the Pokemon value that I have, I would be assigning this image to different Pokemons, right? So we have initialized before these guys here. So these would be the kind of images that I would be using, right? Because I can potentially be reusing the same graphic, right? Then it makes sense for you to create those beforehand before assigning those images. And then finally, you're calling the setGraph method here, and then you would be assigning to that labeled object the image that would be associated with it. I'm doing the same thing for the background. So then at the end of this process, I would be having that graphic associated with that specific Pokemon and that specific background, the white background. Finally, if I want to know the Pokemon type, I have this method that I have implemented here, just returning the value of that enum, that is the Pokemon, right? So this is an example of a subclass of button that has implemented this functionality to work with Pokemon images to present the information. And I'm doing that, I'm using those buttons in a grid pane, right? Is it grid pane? Can't remember. Yeah. So finally, let's take a look at the start method. So my start method is creating a border pane. My border pane is being used on the top region to set this label. So initially it would just be unknown. I'm setting the alignment to centered. Then I am calling the method that constructs my grid pane, and then at the center of my border pane, I am inserting that grid pane. So again, one more example of composing different layout elements together, right? I have a grid pane, and at the center, I would have these, I have a border pane, and then at the center, I would have the grid pane. Okay, is that clear? Right, then the rest is what we saw before a number of times. Let's run that to see what it would look like. So this should present an interface with the label on top, right? And the label on top and the grid with my Pokemons as the elements of my grid, right? And if you observe here, because I did not set any component to left and right and bottom, by default, it would just not be filled in anything, right? If I click here, I would be getting the name of the Pokemon. That is the return of that method that we have implemented in my Pokemon class, Pokemon button class. Okay. Funny program, right? So this is a little bit, as you see, like it's getting a little bit more and more involved, and this is actually getting closer to what I would expect to see in the interface of the program that I have asked you to implement in the homework. Right, that's the last example on specific events. Now let's talk a little bit about the observer and observable classes. As I have mentioned before, the observer class is this class that allows me to define a class that would need to implement the update method. So this update method means that this is a means for my model to tell my viewer that it needs to be updated, right? So again, using as an example the homework, the model of my homework would be the implementation, the logic of the game itself. So let's say something changed in terms of the state of my game. So for instance, you have added a new ball, then you want that to be reflected in terms of how you would visualize that, how you present that, right? So the flow that would happen would essentially the model would receive the comments from the controller. So like these inputs saying that a specific column was clicked or was chosen, let's say the second column, and then that represents you adding a ball to that column or to that pipe, right? So that is the controller talking to the model, and then the model would be using this update method here on all the observers that it has registered to let them know that they should update the visualization, the view, to represent the most up-to-date state of the model. Does that make sense? So you have these sort of cycle, right, between the model, the controller, and the view, and they would be communicating to each other. So similar to what we have in the observer interface, and we have, by the way, we have that implemented on the code that I provided already. So you would actually see that in the plain text UI implementation. You just need to essentially follow the same pattern now for the graphical user interface. And we have one more example here that shows the use of the observers. So here, let me, because we don't have a lot of time, let me just run this to give a sense of the interface that we would be having. So this is just a counter that is being updated every time that I click this button. This number is incremented or decremented. So just a simple counter, right? So I will, because I'm using the MVC model, I will have a model implemented via my counter class. So that's my model. In my model, I would keep a reference to all my observers. And I will have some way to have those observers registered, right? So I would have some way, and that way would be by calling this add observer method. There's a paired interface called observable. So observable is the opposite idea of the observer. That's the model itself, right? So that's also something that you would find in Java documentation. You can look that up. In that specific example here, we didn't implement that, but that's definitely something that you could. Actually, did I? I didn't. Alert the observers. So this is that's what I was talking about before. That's the way that I would let my observers, my views know that something has changed to my state, so they need to refresh their view. And then I have the rest of the implementation. This is super simple, right? It's just a counter, so just one field storing that counter, a method to increment, a method to decrement, and that's it. So in my GUI, very quickly, you would see that you have a JavaFX program that implements the observer pattern of the counter, which is the model that I have. That's the name of the model, right? As we saw, this is a generics interface. So in my init method, I am creating the instance of the model, and then I am registering myself, the view, against that model. And then the rest is just the interface in terms of also registering the events. So similar to what we saw before. Nothing really new with respect to that. That's actually something that I want to comment. That would be the last thing that I would comment today. When we are calling the refresh method, so the refresh method here in my view is what's really updating the values that I have, right? So the number that you see in the counter is being updated by this method here. However, the update method was the one that was invoked by my model, right? So why is it that I have these two steps here? The reason why we usually separate that is because JavaFX is a multi-threaded program. It's a multi-threaded application. So I have no guarantees that the application that would be actually calling that method would be an application of the JavaFX application. So I might have threads that are actually not threads directly related to the JavaFX viewer, right? Because of that, you don't want to call that directly. You don't want to call it directly because you might not have access to that. The model was initialized by my JavaFX thread, right? Remember that I did that in my init method, right? So any other thread would not have access to that. So the way that I fix this issue is essentially just by calling this run later method, and I would just register this comment here that I want to be run whenever my my thread is a JavaFX thread. So I'll be sure that this can be executed. And as you can see here, I'm using a Lambda expression as well. Okay. I'm using the empty parentheses just because I don't have any parameters being passed to the method that is part of the functional interface. So when you have that case, you don't need to specify anything.
That would be to the same, I don't know the name of that method, but it will go to the same method. No.
So that would be determined by the expected parameter of run later. So you would need to check run later to see which functional interface would be expected. That would be a runnable interface. So the runnable, I need to consult runnable to see which method would be implemented by that. Okay. Show quickly that. So the method would be the run method. All functional interfaces only have one single method. Right, that's a requirement. All right, I know it was a little bit too fast-paced to introduce the idea of the Lambda expression, especially if you never had any experience with the functional programming. But I hope that at least the syntax that you saw here, you can just replicate and use in your homeworks. So this essentially concludes everything that we wanted to show about JavaFX. As I said last time, we would begin with the topic on threads. Okay. All right.